All right, as for the rest of today. So, experiments and observational studies. So surveying is a very, very common way to collect data. However, sometimes we want to take that next level. When we still have surveys, we usually call those studies. There are two big types of observational studies: prospective and retrospective. A study is basically when you don't assign choices, right? You simply observe or ask people questions and they tell you the answer. Prospective is when I ask person a question and then follow them to see what happens. The most common example of this is, do you smoke? And then I catch up to you in 20 years and see how you're doing, right? It's always about identifying the subjects, right? And then following them over a period of time. Retrospective is working backwards, looking at a result and identifying in reverse, what did all those people have in common? So a common example of this is we see from death records, all right, that a lot of children were dying from cancer in their teens. So in reverse, we track all these teens backwards, and we notice that 10 years ago, they lived right next to a nuclear waste dump, right? And that's a very, very sadly common thing that occurs. So, but studies, I didn't do anything. I didn't impose anything on those people. I either found a result and worked backwards or asked them a question and then moved forwards. And so studies are very, very simple, and surveying is a type of studies, And so you can get a lot of data, but the strength of the conclusion is usually the big deal here. The strength of the conclusion in an observational study is simply, I see an association. Okay, I see an association between smoking and getting cancer. But I can't say that this causes this. In order to do that, we need to have an experiment. An experiment is much higher level of work, but it's the strength of the conclusion. The strength of the conclusion is cause and effect. I see a cause because I imposed it, and then I see an effect, a result from that cause that I implemented. So, as a note, all of this has a lot of terminology. So notice we didn't really answer a lot of questions. There wasn't a lot of work to be done. This is a lot of verbiage, okay? So just be aware, we got to get through the verbiage, and that is knowing the verbiage to be able to answer the questions. The big thing is a factor. That's the general category of what I'm going to impose on a subject or item in order to get out a response, something that I can actually measure. And this is the big thing. Usually, this needs to be a quantitative variable. Something that I can actually measure so I can see I have an average of this, all right? This average compared to this other average is higher or lower or whatever you're looking for. What you are conducting the experiment on are known as experimental units. And when we have humans, we call them subjects or participants. All right. If you're trying to keep emotional distance, you can continue to call them experimental units. Specific values of each factor is what's known as a level. All right. So the categories within that general thing you are implementing, all the combinations of all the levels of each of the factors is what's known as the treatment. And this is a word that everyone should be familiar with, the treatment group that they are in. Let's look at an example to apply all these words. Is diet or exercise effective in combating insomnia? Some believe that cutting out desserts can help alleviate the problem, while others recommend exercise. 40 volunteers suffering from insomnia agreed to participate in a month-long test. Half were randomly assigned to a special no desserts diet. The other continued eating desserts as usual. We also believe that there may be a difference for the type of exercise conducted. So we had 3 types: anaerobic, aerobic, and none. So identify the subjects Who are we conducting this study on?
Volunteers.
Specifically 40, what kind of volunteers are they?
Random, just like volunteers. Or wait, no, I'm
Suffering from insomnia.
People suffering from insomnia. When someone suffers from insomnia, insomniacs. And there's some nice nostalgia in that as well. What were the factors in the experiment? How many levels of each factor? Okay, so, and here's the big thing of the verbiage here. The factors. This is the general category. So what's the general name of the things we're doing to these people? What are we changing about them? Or about their lifestyles?
diet.
Diet, right? Now, the big thing with factor is diet is all you actually need there. But I like to put on factor diet type because it's a general category, because the diet could be diet and no diet, like the types of diet. In this case, the actual levels of that diet, though, is desserts and no desserts. So those are the types of diets, and we're pretty simple here, right? Dessert, no dessert. What is the other factor we are implementing on these people?
Exercise type.
Exercise type, exactly. Now, again, the type is kind of redundant here. But the biggest thing, the biggest terminology I see people mess up is factors, levels, and treatments, because they're all related, but they are distinct. And then we have 3 types of exercise: anaerobic, and no exercise. All right, how many treatments are there? That's the combination of all the levels. 6, absolutely. How'd you do that so fast? Well, there's not 6 listed there. You did something in your head quickly.
Never mind, I'm wrong. There's only 5.
But there actually is 6 treatments. It's the combinations.
Is it every diet and exercise combination?
Yeah, every diet and exercise combination, which means what calculation do you do? Multiply. All right. There are 2 levels of one times 3 levels of the other. There are 6 treatments. And for completion, I want to list them all just so we can see them clearly. So in order to count them, multiplying the number of levels of each factor. And again, this is we just have two factors, and we're going to keep this relatively small usually, right? At most, I think we're only going to ever see 3 factors because the combos start getting a lot. Once you have 20 treatments, right? That's a lot of treatments. All right, last, definitely not least, maybe most important, the response variable. What am I measuring on these 40 insomniacs to see if a diet and exercise plan helped them? So what is helping an insomniac?
Making them sleep.
Making them sleep, ideally more,
Yes.
okay? So, because by definition, insomniac, does that mean you never sleep?
No.
No, you die. It means you don't get enough sleep, right? And enough is kind of a broad level. Some get 1 hour, 2 hours, 3 hours. Like, so it's all a level of increasing their sleep. Now, here's the other thing, right? We said this needs to be a quantitative measure. Okay, so it's not just sleep, yes, no, right? So how do you measure sleep? Just what variable would you use?
Hours.
Hours slept, right? Simple as that, right? Number of hours slept. Now, we want to go a little bit further because, like we just said, all right, being an insomniac, you could start, right? One insomniac sleeps 1 hour a night, one sleeps 3 hours a night. Okay, they would both be classified as insomniacs. So maybe we want to do percent of increased sleep, right? And that measure could be something amount, right? Hours initially slept divided by hours now slept, something like that. So after the study is now. And so we can identify the percent of increased sleep, right? We have a quantitative variable. All right, I have a number I can count on each person. And that's the biggest thing about the response variable is you have to think about each item in the study and what are you going to measure on them? You don't measure, right? Oh, did you sleep? Great. Okay, well, how do you compare that to someone else who said yes? Right? So you want something that is comparable. And that's why the response variable all right, quantitative. This is why we started out with identifying types of data. Okay? Quantitative, what's the other type of data? Qualitative or categorical. I don't like using Q's for both because it tends to confuse people. But as long as you can do it, no problem. All right? Quantitative, categorical. All right? Numbers, words is the basic difference. All right. So the 4 principles of experimental design. Control. All right. That is basically a baseline, a normal, a usual. You always want that in your study. For our diet and exercise example, what is the usual? All right. Do I have it here among these 6 treatments? What do people usually do? Is it one of these categories? The answer is yes. Which of these categories? What's the standard? If you're not interfering with people, what are they normally going to do?
Dessert, no exercise.
Dessert, no exercise. Right? If you're not messing with someone, I'm going to go home, I'm going to eat my ding dong, and then I'm going to sit on the couch. All right? So you want to make sure that you have the baseline, right? Why are people like, and this is the big thing, why are people always stressed? Why are people always have trouble sleeping? Well, if you never exercise, your body never gets tired and you eat dessert, that's sugar. All right. This is actually a really, really good control for this type of study. Okay. So other principles. Randomize. All right. People don't get to choose. That is what makes an experiment and not an observational study. When you collect, right, with our 40 insomniacs, they don't get to choose what group they're in. All right, they already chose whatever group they were in. We put them all in a baseline and we randomly assign them to a group. That's what makes an experiment. Replication. This is actually twofold. One, you need multiple subjects within each treatment group. A 1-subject treatment group is not a treatment group, that is observing. That is anecdotal evidence. We want real data that we can analyze. You can't take an average of one person. Also, replication also means someone else has to be able to recreate your experiment. I see it way too often in psychology where they run all these studies, but no one can ever repeat it. Okay, and it's not because it's cost prohibitive, it's because their experimental design was so bad that they can't explain to someone else how they did it. So you need a study that can be reproduced. All right, because that's what real data is. And then blocking. This is only an if needed idea. Blocking is identify an attribute that you can't randomize out. All studies have sampling variability, all experiments, everything. Okay, but sometimes things affect people, could be objects, but people differently. What is the biggest difference between humans? Specifically, maybe sleep. Let's do something else. Weight loss. If I was doing weight loss, what would be something that I think there would be an instant difference if I have two random?
Metabolism.
Okay, even that's related to what I'm looking for. More even general. I see 5 people in here. All right. Gender. All right. Weight loss. Does weight affect men and women differently? Yes. Study after study has been done. Okay. Does sleep affect men and women differently? I don't know. All right. There probably is a study out there that says yes, because gender, one of the biggest things that we have to block for is gender. All right. Because can I randomly assign gender? No. Okay. So that means that's an initial something I block at the beginning. Along those lines, the best way to identify, all right, and to kind of graph out an experiment is to diagram it, right? We're all about pictures. Well, we had to have a picture coming up soon. So I want to diagram out the diet and exercise experiment. We start with our 40 insomniacs. Then those go in to treatment groups, which we've already listed. And we need to list again. Okay. RA random assignment. I'm going to come back to this in a minute because that's actually the biggest part of this diagram. But basically, we start with 40 insomniacs. We randomly assign them into the groups and basically break them up as evenly as possible. So assigning a number of people to each group. So 6 divides 36 is 6. So a couple groups with 7. And it doesn't actually matter. It doesn't have to be like matched up. Basically, I just start going 7. So break it up as evenly as possible. Now, here's the other thing. If I was designing the experiment, and sometimes we're limited on people, which is why I wanted to show this. But if I'm choosing this experiment, you think I could find 2 more people with insomnia? Yeah. So it's always easiest. you diagram this out and I go, oh gosh, the number I picked didn't work. Maybe if I did 42, then I have all groups as 7, which is even better. And actually the diagram then comes to the end, compare percent of increased sleep. So notice what this actually identified. I have my response variable, I have my treatment groups, and I have my subjects here. This doesn't have the factors or the levels. I mean, you can identify the levels from here, but basically, when we identified this individually, we found all the pieces already to put this diagram together. But sometimes you can jump straight to the diagram. And that's why this is our picture associated with experiments. All right, so back to the RA, which is a big part. RA means random assignment. And this is what makes an experiment an experiment. So we have to be very specific here. With the first person, all right? So for each insomniac, I need to randomly assign them to one of the treatment groups. Again, they don't get to choose. How many treatment groups do I have again? 6. Is there a object that randomly assigns numbers 1 to 6?
A die.
A die. All right. So basically, for each insomniac, roll a die. Now, again, this is the general way. Technically, we would do a random number generator, but we want to just explain the concept. Roll a die and assign the subject to a group as follows. Roll a 1. Desert aerobic. Etc. And then as a note, is it possible I roll 7 1s in a row? Yeah, okay. So on the 8th, so I roll again, on the 8th roll, I get another 1. What do? Right? It said 7 insomniacs. That group is full.
Make another,
Do what?
make another group.
Make another group?
Or I should say, could we just like separate 20 people? Another 20 people?
What? I was like, that group is full and I only have a limited number of people.
Just get rid of that group and then continue, like get rid of that number and continue rolling.
Right. AKA, if the group is full, re-roll. Again, just being specific, because I just see that so often people are like, oh, I don't know what to do. I rolled a 1 again. Well, you just roll again, right? Also, the other thing is the other mistake is I see people, oh, we'll just dump them into group 2. That's still not random. That's not random assignment. Okay. The actual thing is the die is in full control. Okay. You're not choosing anything. Okay. So the random assignment, this is the part that actually makes an experiment that people do not choose. All right. We choose for them. All right. So now I want to go off and I say, okay, assume that insomnia affects men and women differently. And this is just a basic assumption. Okay, maybe we believe. All right. I want to diagram the new experiment and now assume I had 20 women and 20 men. Now, the good news is that diagramming this experiment is still very, very similar. But we start with the block. So just like we have RA, this immediately breaks into 20 men and 20 women. Because I cannot randomly assign. There is no RA here. The RA still comes in the next stage. Okay, so the RA, and the good news that our RA is still exactly identical. I'm going to roll a die and I'm going to assign, right, the 20 men to a treatment group just like we did before. Then I'm going to roll a die and assign the 20 women to a treatment group. But basically, all a block does is it means that you're conducting really two parallel experiments. And in this case, we have a smaller sample size, right? So now I have 4 men. Oh, 3 men. The benefit also comes, all right, since we were trying to identify, okay, is there a difference, right? We said assume, but the whole point of the experiment is I can actually see if I can prove this. So in the initial experiment, we brought it all back together and said, just compare, all right, the results. But bringing this back together is actually twofold. Okay, so this was the men category. So I had all the men here. we compare them individually. So we say compare percent of increased sleep among men. Similarly, compare percent of increased sleep among women. And then, all right, just like we do over and over, the concept of dependence, all right, independence. If I have the, let's say, the average percent of increased sleep among men and the average percent of increased sleep among women, what do you think I should do with those two numbers?
Compare.
Go ahead.
Compare.
Yeah, then we can compare them to each other. And that is the other benefit of blocking. So then compare percent and then we could actually see if there is a difference, right? We said assume, but I don't know. All right. This particular study probably has been done. Okay. But that's the idea. When you have a thing that, oh, maybe there's a difference between men and women, some race, some eye color, some hair color, something that you can't control. All right. That's what a block is for. Now, as far as the actual conducting, this didn't change the conducting of the experiment basically at all. All right. I still have 40 people and I'm still putting them into various diet and exercises. I just have a nice representation of men and women in each treatment group. Switching it up, looking at a different example. So for 100 inmates, all with a clean bill of health, I want to conduct a completely randomized experiment to find the relationship between smoking and lung cancer. Identify the factors, levels, treatments, response variable, and diagram. So I bring this up because still to this day, all right, there's a joke. We say smoking is the leading cause of statistics. And the joke is simply because for anyone familiar, on a pack of cigarettes, does anyone know what it says? There are actually 31 different labels. What is the most common label that's out there?
Will cause cancer.
What?
Will cause cancer.
Does it say will cause cancer?
Hey.
Did you say may? I just didn't hear you.
No, I saw.
Okay. All right. Yes, the most common label on a pack of cigarettes is smoking may cause cancer. It is 2024. How do we not know this? And the reason is simply we have never done a completely randomized experiment. All right. Now, it's statistically not proven, right, in the fullest sense. Does smoking cause cancer? Yes, obviously. Okay. But, all right, the tobacco companies, the geniuses that they are, they have been using statistics on their side forever. Okay. Because they know the actual stats. All right. Fun side note. Stats is also referred to as the sin science because the people that hire the statisticians the most, well, technically, politicians hire them the most. All right. But the other private industries, all right, tobacco, what are other things that get a lot of flack? That kill a lot of people. They kill.
Pesticides.
Guns.
Guns. What other thing kills a lot of people that everyone does all the time?
Bread.
Drink.
Alcohol. All right. And then the last one, gambling, obviously. All right. That not the killing. I was like, but hired, that is a sin that hires a lot of statisticians. the legal establishments hire a lot of statisticians.
Don't look up.
The back alley gamblers, they don't need a statistician. So anyway, I was like, those 4 industries use more statistics than anything else because they make these kind of arguments, which are completely logically sound. All right, so anyway, back to the concept here. Okay, so I want to identify the factor. So we can identify some terminology and then diagram this out. Okay, so what's the factor? What is the general category of what we want to do to these 100 inmates? And as a note, the reason I've chosen 100 inmates is because why?
They usually use cigarettes as a currency in jail.
That is a really funny reason. But remember, we want them smoking them, not trading them. All right, so any study that is not medically helpful almost gets shot down immediately. The FDA is borderline a rubber stamp, and it has been long before COVID, okay? Because basically, so many things don't go through studies because you can't be, let's say they come out with, oh my God, the miracle cancer cure. They have to just give that to everybody. I mean, cells, okay? They have to just allow everybody to get that. They can't run a study to prove how good this miracle cancer drug is, all right? So, because if I have 100 people with cancer, in order to actually compare that, 50 of those people have to not get the cancer drug, right? And then 50 of them do. But simple as that, okay? But there's so many guidelines. So basically, in order to actually do this study, something that could be potentially harmful, I need to select people that ideally gave away their rights already. Okay, sorry, anyway. So what is the factor? What is the general category that I'm doing to these inmates?
Those who are smoking versus those who are not smoking.
Okay, that's the levels, and this is what I was talking about. So technically, right, we have 2 levels, smoking and non-smoking. So what is the factor? What is the general category? No, that's the subjects, and I,
Oh, it'd just be smoking that, wouldn't it?
yes. And better than that?
Smoking, causing blood cancer.
That's kind of the result I'm looking for at the end. What word did I say it's good to add on here? Type. And for this reason alone, smoking, and then one of the levels is smoking, all right? It kind of confuses the issue. So that's why I always like to add smoking type, because representing the factor as that is the general category. What are the types of smoking? Well, there's smoking and non-smoking, okay? And so we want to make sure we can distinguish between these, because this is where all the verbiage starts to get really like it starts to overlap so much that you can't distinguish. Okay, the treatments, when you only have one factor, the treatments and the levels are exactly the same.
That's not confusing at all when you're labeling.
Right? So that's easy, but then it's, oh my gosh, it's like the same thing repeated, right?
Yeah.
All right, and then last, but definitely not least, okay, response variable. Remember, what kind of variable is the response variable? Quantitative. So really, when you think smoking, right, and our result, I'm thinking, what do I want to see about these people?
The effect if they had lung cancer.
Cancer or not? Yes, cancer, yes, no. What kind of variable would that be? Cancer, yes, no.
Cancer, no cancer.
Yes, what kind of variable is that? Categorical.
Oh.
All right, that's a categorical variable, which means that that's not a good response variable for an experiment. So what is something quantitatively you can measure? That's so, because remember, on each person, I have to ask them, something or have to record something on them. The percentage is an overall category because on each person I just asked, do you have cancer or not? Or I measure if you have cancer or not. So, all right, anyone know anything about cancer?
Coffee.
What?
A lot of coffee.
The stages.
Stages is one way to go. All right, but basically stages only go 1 to 5. Severity is actually really close. All right. Cancer is actually, all right, they have stages of cancer, but with each stage, they're meeting certain criteria. So there's actually a whole list of cancer indicators. So possibly the best response is number of cancer indicators. Does the person have jaundice? All right, are their lungs shutting down? Are their blood vessels blowing up? Right? What's their white cell count? Right? There are lots and lots of things. So something to that nature. On a different note, all right, about smoking, is there something else kind of measurable? Right? Did anyone, like when you were kids, you know, and that you go in and you get to hold the lung between the cancer and the non-cancer? What is it? What's the difference? Person that smokes, what kind of lung do they have?
Pink, healthy lung, and then you get this shriveled black mass.
Right, black, because what do cigarettes have? What does it result in the lungs? Does anyone remember? Do they still do this? I know I'm older, but.
I know what you're talking about. We did it back in middle school.
Okay, so tar, right? So that's something. So as a note, and there are lots of options here. This is the best one by far, but I could also do, you know, something along the lines of pounds of tar in lungs, which is probably closer to a cancer indicator than anything. Okay, but again, my point is, make sure that you're thinking about a quantitative variable, and you have to measure it on each subject. And that is the ultimate temptation, because so often we're trying to be like, oh, well, I want to find everyone who has cancer, so I'm just going to ask them cancer, yes, no. We need good measurable data so I can say, the average number of people that smoked, their average number of cancer indicators are 100. The number of when the people didn't smoke, the average number of cancer indicators was 5. Is there a clear difference there? Yes, and you want to think about what your result at the end needs to be. All right, let's diagram that out. And again, the diagram is also very easy because notice we didn't have very many factors. We didn't have very many treatments. I mean, the diagram is actually very, very simple. So I have 100 inmates. Breaks into 2 groups. And the numbers break up nicely as well. All right, and then, all right, just like before, we need to identify what is the role of randomization in this experiment. So, do I have a random number generator object that breaks things into 2 groups? A coin. Oh, see how this math worked? Now, as a note, now we did the 2 most common, right? A coin and a 6-sided die. But be aware, whenever you're doing this, you can always go back to a hat with however many, if you have 7, but also be aware, for anyone unfamiliar with dice, all right, God bless the geeks of the world, because dice come in sides from basically 1 to 100. All right, they have made dice of all sides, so every time you can say, get a 7-sided die, get a 9-sided die, all right, and then break up the groups as such. All right, And because there's only two groups here, once your first group is full, everyone goes to the other group, right? This only actually works when there are two groups, right? Otherwise, you would continue to re-roll or reassign, all right? But technically, in this case, when the group is full, assign everyone else to the other group because the randomization is done. You can keep flipping until, assuming the heads group was full, you can keep flipping until you get a tail for each person, but no point. Okay. So here's the big thing, nature and scope of the conclusions. Observational studies, which are way easier to do because it's way easier to do a study where people choose what group they're in. And this is why smoking has remained a quote mystery as far as cause and effect. Because people choose to smoke, and then we seem to see this association with them getting cancer. Now, the tobacco companies have continued to argue, oh, well, it's socioeconomic status, it's race, it's ethnicity, it's shoe size, all right? Because they know that we cannot definitively say smoking causes cancer, all right? So be aware, all right? It is the strength of the relationship. Now, do we do tons and tons and tons of observational studies? Absolutely, because they're way easier to do. Experiments, even something as simple as the diet and exercise example, is hard to conduct because people, what do we not like? As people, we don't like being told anything, all right? Chloe, you are in the dessert and no exercise, let's say that. Did you eat your ho-ho today? Right? No, you didn't. You need to eat your ho-ho. Did you exercise? It looks like you just showered. You can't exercise. You're in the no exercise group. Just making some, or on the other side, right? Whoa, Bella. It looks like you have a crumb. You're in the no dessert group. You can't eat any desserts, right? Whoa, did you lift weights? You're in the aerobic group. You can only run, right? And so that's my whole point. Getting people to follow their regimen and something like that. How long do you think that study would have to be?
Few years,
Doesn't need to be years,
months.
but probably a couple months, right? I mean, in order for some good results, okay, insomnia doesn't just heal overnight no matter what the regimen, okay? A good study, maybe a couple months. That means those people have to remain in their groups and follow their treatment protocols for 2 months. And people hate that stuff. The strength of the relationship is great, right? We would, and ideally something along the lines of, I'm guessing no dessert and aerobic or anaerobic might be a judgment call of which one's better, okay? But I could then say at the end of the study, right? If you do not eat dessert and you are in the anaerobic exercise group, that causes, all right, you to have increased percent of sleep. And we could even say by however much. So the strength of this relationship is very, very strong, but it is hard to conduct experiments, especially on humans. And this is why also you see in a lot of studies, they say, oh, whatever, 60% compliance, because so many people just drop out of the study because they don't pay a lot, all right? Ideally, they're solving a particular issue, okay? But that is the downside. So, as I said, control groups are absolutely imperative. We need a control treatment. Now notice, back to our smoking one. We only have 2 treatment groups. We only have 2 treatment groups. Is one of these the control group? Is one of these the business as usual group? What do most people do? Specifically US. According to recent US data, do most people smoke or don't smoke?
Probably smoke.
It's not.
Really?
80% of the US does not smoke, 20% does. And that includes updated numbers. I just looked this up just like 6 months ago. That includes all tobacco and vape use. So this is the control group. Actually, fun fact, smoking studies have barely changed, all right? Not smoking studies. Smoking data has barely changed in like 70 years. The difference is actually the particular breakdown. People smoking cigarettes has decreased, but in order to compensate, what has increased?
Price of cigarettes.
Vaping or e-cig, yeah, like, I mean, whatever that comparison. So people using tobacco has decreased, but people using nicotine overall hasn't changed at all. The percentage of people using smokeless tobacco and smokeless, okay, whatever it's called, smokeless vaping, whatever the equivalent is called. All right, so none of these numbers have changed. And in the US, it's still 20% smoke, 80% don't. So again, for your knowledge, there are some additional things that we can do to increase or even make studies effective in general. Blinding is a big one. So blinding comes down to the concept of if your personal biases are involved. And this is most common with something like Coke and Pepsi, right? Everyone has a preference of, oh, I like Coke, oh, I like Pepsi, all right? But if I tell you, right, let's say you like Coke and I say, here's a Coke and here's a Pepsi, which one tastes better? You're gonna be like, oh, the Coke tastes better, all right? So blinding is when we hide the treatment groups from you and then give you a blind taste test. That's single blinding when the subjects don't know. Double blinding is when both the experimenters, specifically the one conducting the experiment on the ground, and the subjects don't know. And that comes into play in the neighborhood of, if I know, right, I work for Pepsi, and even though I give you 2 jugs of dark soda, I'm gonna be like, which one tastes better? While I'm being like, I think it might be the left one. I think the left one tastes better, all right? So you can't blind everything, but some things need to be blinded to be effective. Can we blind if someone is smoking or not smoking? No. If you're smoking a cigarette, I think you know you're smoking a cigarette. Can you blind the kind of exercise you're doing? No, right? I think I know if I'm lifting weights or not exercising, right? So not everything can be blinded, but when it can, all right, and this is very, very common for drug trials, all right? Again, low stakes drug trials, all right? With low stakes drug trials, because they want to see if a particular drug is effective, and that's how they do it. The placebo effect. The placebo effect, you may have heard of this. The placebo effect is real. By telling you something, all right, and the biggest way is by telling you something and then giving you the magical pill, all right? As Americans, we love our pills. So by giving you the magical pill and saying, this is a sleep aid, people sleep better. And sleep drugs are by far the one that suffers from the placebo effect the most. That's why the real sleep drugs, they have such massive side effects. Because in order to break the concept of just telling you you're going to sleep better, people sleep better so often. That's why the real drugs are like, oh my gosh, like, take 5 hours before bed, don't be near a car, lock all your doors, because they kept having people wake up and they're like in a different state because of the side effects of sleep drugs because they're so hardcore. And it's in order to break through the placebo effect. Right? There's all kinds of anecdotal evidence out there of like people growing back arms. None of this can ever seem to be replicated, okay? But it's because it's all based on the concept of this gets you better. And so people just get better. We are trained to know that pills make you better, all right? And so telling you a pill does something, it it has what's known as the placebo effect. People just get better. Along those lines, the biggest thing about a placebo effect. So here I have a group of 4 different groups. 3 of these groups are placebo groups. All right, so I have aspirin and beta carotene, aspirin and beta carotene placebo, aspirin, placebo, and beta carotene, aspirin, placebo, beta carotene, placebo. If one of these groups suffers from the placebo effect, all of them do. All right, so just be aware that it's not only the ones with placebo in the name, it ruins the entire study. And that's the biggest problem with the placebo effect because it becomes very, very expensive. All right, as soon as one group improves from whatever we're trying to do, this was about like actually cardiovascular disease reducing. But if any of the groups improve, all right, the whole study is ruined. And I just want to make that clear. Another big term that we talk about is confounding. Confounding is about when you're trying to run a study, but something else in the natural environment, all right, is also happening. And it's impossible to separate out your results of your study from possibly what happened just in the world. So a professor taught his class, all right, in 2 identical semesters with the same text, same syllabus, same course, office hours, everything. The only thing he modified was his teaching style. In the fall, he taught very mundane, monotone, didn't say anything different, talked the same the whole way through. In the spring, he taught with lots of movement and pitch changes and run around the classroom all excited. He noticed on a 5-point scale, the difference in his average course score went from a 2.93 to 4.05. Okay, so massive increase there quantitatively. What was more interesting was the amount of comments that also increased. People praised, all right, his accessibility. He had the same office hours. They praised the book. He had the exact same book. Okay, they praised all kinds of things that were absolutely identical. Well, what's the big difference between fall and spring semesters? Just anywhere, not just this happened to be conducted in Ithaca, New York, but in general, Wyoming's a good example. Season, all right, right? In the fall starts out happy and beautiful and nice and ends cold and wintry. Spring starts the opposite. It starts horrible and wintry and ends into summer, right? So season is a confounding variable. For those right are familiar, evaluations are always at the end of the semester. So in the fall, they're closer to winter, right? In the spring, they're closer to summer. Is the difference because of season, or was it because of the professor's change in demeanor and how he taught his course? We can't tell. The only way to actually tell this is to continue to repeat this study. So this is the concept of the best way to get rid of a confounding variable is continued replication.
Or if you switched it, did the,
Or try, and that's what I mean by replication. So next year, now we do the excited one in the fall and the monotone in spring, and then continue to repeat it over and over. And that's the whole thing. In this successive term, that is it. The season is a confounding variable, and I can't tell the difference. You're absolutely correct there. All right, so as a note, the best experiments are randomized, comparative, double-blinded, and placebo-controlled. Again, I cannot always have all these things. I can always have randomized and comparative. You should always have comparative. That means you have a control group in there. Double-blind, we just talked about. You can't always have blinding. And placebo-controlled. Now, ideally, placebo-controlled is something I can't have. By telling you that you're smoking a cigarette, right? So let's pretend we made a bunch of fake cigarettes in order for the other control group. I made a bunch of fake cigarettes, and then I tell you you're smoking a cigarette. Are you going to develop cancer? I don't know, but that's how I would placebo control that. right? We would make cigarettes that look identical. We could even put them in the Marlboro box and, you know, you open them and it looks identical, right? The thing missing would be this, and somehow we'd have to match the taste and all that stuff. Okay, but that's how you placebo control something like that. I can't quite placebo control someone with the diet and exercise, right? Oh, you're not eating a dessert, so you're gonna sleep better. But the idea is, if possible, these are the best experimental designs. All right, so just some notes, and a lot of this was from when I was consulting, actually. I saw people come in and this goes along the lines of your project, all right? If you're trying to flesh out your ideas of your project, don't spend all your time and everything on your first run. Make sure your idea is fleshed out and collect a little bit of data first before you go out and do that massively. Because if you go out and collect a bunch of bad data, there's nothing to do but just start again. Bad data from the start often can't be salvaged. You want the best data from the start that you can, which means, and this is the concept of don't spend your entire budget, and for you guys, time is money. Don't waste all your time running this, going and collecting all this data, and then it's all junk. All right? Okay. That should be everything.